Hey guys, and welcome to another one of my tutorials. So in this tutorial, we'll be going over how to set up a physics-based slide in your game. So essentially what I mean by that is the slide will be affected by the slope that you're sliding on. So you can see if I start sprinting and crouch, it will do a slide. And if I do it on a flat surface, then it just basically does a normal slide. But if I do it down a slope, you can see it slides me down the slope and I kind of gain speed as I go down it. If I try to slide up something, it will actually stop me pretty early because I'm going uphill and I'm losing momentum. It also takes the way you're sliding and moves you along the slope. So if I slide at an angle here, you'll see I actually kind of slide down the slope a little bit. So it both also both speeds you up and it also slides you in the direction of the slope. So just to give you a better example, if I go under this thing, if I start all the way up here at the top, I can slide from the top and I'll actually slide all the way underneath this little hole down here. So it's a pretty cool mechanic. And you can totally adjust like how slidey it is if you want to think of it that way and make some modifications to it once you finish. But some other things I just want to point out real quick that's pretty cool. It works pretty well over like rough terrain. So if you have some bumps in your terrain, it's not going to like totally break everything. You can still slide over it just fine. It also handles walls well. So like if you slide up against a wall, it will just slide you along the wall as opposed to stopping you. And of course you can slide under things. So normally I can't walk through this, but when I slide, it will actually slide me under it. And so the way this is set up is that if I hold down the shift key, it sprints, which is really just increasing my speed. And I just added this because the way the sliding works is that if you shift and then you press the crouch key, it does a slide. And if you just press the crouch key, then it just does a normal crouch. So we'll also be kind of hooking up a crouch and a slide in this tutorial as well, because you kind of need that in order to have a slide. But the main point of this tutorial is the slide. And then one other thing that's kind of cool is that if you slide under something and you kind of get stuck in the sense that there's not enough room for your guy to stand up, then the system will keep you crouched until you walk out of it, and then it will automatically uncrouch for you. All right, so with that being said, let's just go ahead and jump right into it. So what I've done here is I've already created a new project. So this is just a totally new project. Let me move this guy off to the side. So this is just a totally new project using the first person template. So you can see just has this familiar little guy with this little gun that he shoots. And that's all that is. I haven't made any modifications to this because I wanted to do this totally from scratch. So the majority of this code is going to be added to the first person character. So let's click on this guy and say edit first person blueprint. And the way we're going to be doing this is pretty similar to how I do a lot of my other tutorials, is that we're going to be creating the functions and the variables that we need ahead of time. And then once they're all created, we will go through and start actually coding it and hooking them up. I just find it a lot easier that way, and it kind of creates a structure for us ahead of time before we actually start coding. Okay, so let's do that first. So over here on the left, we want to add a new graph. So we'll say new graph, and we will call it the movement graph. And so the reason we're doing this is just purely for organization. Just so we can add all of our events and stuff that have to do with the movement into this graph, and so we don't have to clutter the event graph. And so we'll be filling this out here in a second. Actually, I guess we can just fill it out now. No reason not to. So the first thing we're going to need is some input bindings actually before we can create these. So let's come up here to the top and go to edit project settings and then go to input on the left. And we want to add two action mappings. So we want to add one for sliding and one for sprinting and one for crouching. So hit this little plus key or plus button, and we will call this sprint. And then I'm going to hook this up to the shift key, the left shift key. And then we want one more for crouch. And I'm going to hook this up to the C key. So you can set these to whatever you want. These are just the ones that I'm using. And again, we don't need one for sliding because the sliding is activated whenever you sprint and then crouch. So we don't actually need one for sliding. Okay, so we can come back here now to our movement graph and we can right click. So we need an event for the sprint. So we can say input action sprint. So this is going to get called whenever the shift key is pressed. We want another one for when we crouch. So we'll say input action crouch. And this is obviously going to get called whenever the C key is pressed, or the crouch key. And then we want to set up a series of timeline nodes. So those are going to get created, or those are going to get activated by custom events that we're going to just call begin and end. So we want one for crouching. So we'll say add custom event, and we'll call it begin crouch. And then we want to have one for in crouch. So we'll say add custom event. We'll call it in crouch. And then likewise, we want to have one for sliding. So we'll say down below, we'll say add custom event, and we will call it begin slide. And then just like we did before, we're going to add another one for in slide. So add custom event, call it in slide. And then if you noticed from my other video, I'll just run it again real quick. When I slide, there's actually a little bit of camera tilt. So we want to have some events to handle that. So we'll say add custom event, and we will call it begin camera tilt. So this is going to get called whenever you start sliding. And then we're also going to have another custom event, and we will call it in camera tilt, which obviously gets called when we finish sliding. And then we're also going to need to make use of the event tick. So we'll say event tick. So if you already have an event tick in your game, then you don't have to add this here. We can just add the code that we're going to be adding to event tick to wherever your event tick already is. But since I don't have one, I'm just going to add it down here. Okay, so these are the events we're going to need. We will fill these out shortly. Now that we have that, let's come over here to the left and create some of the functions we're going to need. So hit this little plus button on functions, it will add a new function. The first one we want is going to be called resolve movement. And so this is going to be a really helpful function. It's basically going to, well, do what it sounds like. It's going to resolve the movement to whatever the movement should be. So for example, if we're holding down the crouch key, and that's the only button we're holding down, it's going to set us to crouching. If we're not holding down any keys, it's going to set us to walking. So it's kind of going to figure out exactly what movement mode we should be in, and it's going to set us to that. We also want to have one for setting movement mode explicitly. So we'll hit the plus button again, and we'll call it set movement state. Oh, and I forgot. So we want to add these to a crouching or a movement category just to keep things organized. So click up here on resolve movement, and let's just add this. If you change the name, we'll just call this movement. And you can see that adds it to a movement category. And then we also want to make it private just because we don't want anybody else accessing this function outside of the class. And then let's just take our set movement state and drag it into the movement category. And then let's set it to private as well. Okay. And so from here on out, we'll just duplicate these functions so that all this stuff gets copied along with it. So we need a few more. So let's right click and duplicate this guy. And we will call this one on movement state changed. So obviously this is going to get called when the state changes from one to the other. So like when we go from standing to sprinting or crouching to sliding, it's going to call this function. And inside of here, we can handle anything we need to do when the movement state changes. The next one we want is going to be called, oops, don't do that, just duplicate, so that way it keeps everything. So duplicate and call it calculate floor influence. So what this function is going to do is it's going to eventually look at the slope of the floor and figure out how it should affect our slide. Like, should it speed us up or slow us down, and what direction should we move in? And then finally, the last two we want are just going to be, oops, I keep doing that. Just if you duplicate it, it makes it a lot easier. So we'll duplicate and we'll call it can sprint. So this is just going to be a simple little function that returns whether or not we can sprint. And then let's duplicate this and we'll make one more and call it can stand. And so this one's obviously going to be used for when we're crouched underneath something and we let go of the crouch key. It's going to check if we can actually stand or not. Like, is there enough room for us to stand? Okay, and then before we keep going, let's go and create one quick little enum. So if we come back here to our content folder, we can right click. We want to go to blueprints and we want to go to enumeration. And we're going to call this e movement state. So what this enum is going to do is it's going to keep track of the current movement state we're in. So for this project, we're going to have 4 of them. So if you double click on this guy, let's hit the new button 4 times. So 1, 2, 3, 4. And then we want to just name these appropriately. So the first one is going to be walking. And this is actually technically going to, it's actually for walking or standing, but we'll just call it walking. And then we want one for sprinting. We want one for crouching. And we want one for sliding. So obviously, oops, I spelled that wrong. So, you know, depending on which movement state we happen to be in, it's going to be set to the correct one accordingly. So we can save this and close it. And then over here on the left, we want to start creating some functions. So the first function, or sorry, some variables. We already created the functions. So we want to start creating some variables. So let's hit this little variable button. And the first one we want is going to be called movement state, which is going to be of type of that enum we just created. So we'll call it movement state. And then if we hit this little button here, we can change the type of it to be movement state. And again, make sure you select movement state and not movement mode. Movement mode is something else. And movement state is the one we just created. So make sure you select movement state, like all throughout this tutorial. Okay, so this is our current movement state. So this is going to keep track of what state we're in, like if we're walking, sliding, crouching, and so on. And so we want to take this, and we also want to move this to a movement category just to keep things organized. And then we also want to set it to private so that nobody else can access it. All right, so we're almost done creating or setting up things. We just need to create a few more variables here. So let's duplicate this guy, and we will call this sprint key down question mark. And we will switch this to a Boolean. So this is obviously whether or not the sprint key is currently down. And we want to duplicate that. And we also want to keep track of whether or not the crouch key is down. So we'll just duplicate and rename to crouch key down. And then we also want to keep track of our the half height of our capsule when we're standing. And we need this because when we go from standing to crouching, we're going to shrink our capsule. So it's going to get actually a little bit smaller. So that way we can fit underneath things. But then when we uncrouch our capsule, we want to know what we need to set it back to. So we need to keep track of that value. So if we duplicate this guy, we will call it the, oops, it's not typing. We will call it the standing capsule half height. And we want to make this a float. So change it to a float. And then we also want to keep track of the same thing, but for the camera's offset. So duplicate this, and we will call it standing camera Z offset. Okay, so now we have pretty much all the variables and functions that we need. So if you compile and save, it should all compile and save just fine. And so from here, we can start going and filling out our code. So let's go to the movement graph, because that's where a lot of it is going to be. And so up here at the top, we have our input action sprint. So let's just start here and we'll start filling things out as needed. So when the sprint key is pressed, the first thing we want to do is we want to drag in our sprint key down, and we want to set it to true so that we know that we're sprinting. And then the next thing we want to do is we want to actually set our movement state to sprinting as long as we are in an appropriate state to do that. So what I mean by that is we want to look at the movement state. So if we drag in this guy and say get, and then we drag up to this, and we say switch, we can check the current state that we're in. And I'm actually going to take these two nodes and make them into a macro just because we're going to be using this all over the place, and it'll just be a little bit easier if it's in a macro. So if you take this, highlight both of these, right click, and say collapse to macro, it will turn it into a macro. And then on the left here, we can just rename it to switch movement state. And then if we come inside of here, and we want to hook up the output to the output. So we'll say walking. If you just drag it onto the top here, it will create a pin for you and hook it up. And so we just want to do that for each one of these guys, like so. All right, so now if we come back here to our movement graph, you can see it's just a little bit cleaner. And so if you think about it, when the sprint key is pressed, we only want to actually start sprinting if we are currently walking or if we are crouching. Because obviously if we're sprinting, we don't need to change it to sprinting. And if we're sliding, we also don't want to start sprinting because we're in the middle of a slide. So from here, we want to say set movement state. So drag in this guy and hook it up to walking. And then I'm just going to double click to create a little reroute node and hook it up to crouching as well. So we want to be able to specify here that we want to set it to sprinting. So let's go and set up this function. So if we double click on set movement state, we want to add an input pin. So click on this guy and add a new parameter, and we will call this we want it to be of type E movement state. So select movement state, and we'll call it the new movement state because this is the new one that we want it to set to. And so the first thing we want to check inside of here is whether or not this new movement state is equal to our existing movement state. Because if it is, then we don't really want to do anything. So we'll say not equals, and we will hook that up to the movement state. And then we will do a branch and hook that up. So if it's not equal, then of course we actually want to do something and we actually care about it. So the first thing we want to do is we want to save our movement state. So that way, after we change it, we'll know what the previous one was. So down here at the very bottom left, let's make a local variable real quick. And we'll just call this prev for previous. So prev movement state, and then in parentheses, I'm going to put local, just because I like to specify which variables are local. And then if we hit this little button, we want to change it to be movement state. And so we want to take this guy and drag him in and say set and hook that up to the true. And then we want to save our movement state. So if we drag in our movement state and say get, we can hook it up right here. So it's basically just saving our movement state right before we change it. So let's go ahead and actually change it now. So drag in movement state and say set, and then hook that up. And then make sure you've compiled, otherwise this next step won't work. So make sure you compiled. We want to drag off of this and say get new movement state. And it's like that. And of course, this variable is just this input parameter over here. You could just drag this pin over if you really wanted to, but it's kind of ugly, so I like to just do this. Okay, so basically we've made sure that the new movement state is different. We've saved our current movement state into our previous movement state, and then we've updated our movement state to the new one. So now that it has changed, we want to call on movement state changed. So hook this up. And so let's go inside of here and fill out this guy real quick, or at least start filling him out. So double click on this. And so this needs to take in what the previous movement state was. So we'll add an input parameter here, and we will call it pre-movement state, and make sure it is of type movement state, like it is right here. And so we want to add a sequence because we're going to be doing a couple different things. So if we hold down the S key and left click, it will create a sequence. You can also create one of those by right clicking and searching for a sequence and selecting this guy. So we want to make a sequence. So the first thing we want to do is we want to adjust the speed of the character, because obviously if we are sprinting or walking or crouching, the speed of the character needs to change. So to change the speed of the character, we can drag in our character movement component, and we can say set max walk speed. And so whatever we pass here is going to basically be the speed that he can move at, whether he's sprinting, walking, or crouching. And so to determine what we want to pass here, we need to determine it based on the current movement state. So if we drag in our movement state, and then we can use the select node. So we'll say select, and we can hook that up to the max walk speed. And so now you can see all we have to do here is fill in whatever we want his speed to be at these different values. So what I'm going to do is create constant variables for each one of these. So if I right click on the walking and say promote to variable, it will give us a new variable, and I will just call this the walk speed. And then we want to take this and we want to move it into our movement category. And then we also want to select blueprint read only and private. And the reason we're selecting blueprint read only is because this is just a constant value. It's not something that's going to be changing at runtime. So for that reason, I'm going to make it blueprint read only. And private, obviously, because we don't want anybody else modifying it. And I'm also going to add it to a subcategory. So if you hold down the shift key and hit the backslash, which is the button right below the backspace and right above enter, it'll create this vertical pipe. And that'll create a subcategory. And so we want to add it to a subcategory called constants, since it's a constant variable. And again, this is not anything you have to do. This is just what I like to do to keep things organized. And so now you can see it's added it to a subcategory called constants. And then we want to create one for sprinting and crouching as well. So if we duplicate this guy, we will call this the sprint speed. And if I duplicate him one more time, we can call it the crouch speed. All right, and then we can hook these guys up to the appropriate spots. And we don't actually need one for sliding, and you'll kind of see why later, but while you're sliding, you're not going to be using the walk speed, you're going to be using something different. So it doesn't really matter what you pass here because it's not going to be used, so we can just leave it at 0. Okay, so make sure you compile, and then we want to set these to the appropriate values. So for walk speed, I'm going to set it to 600. For sprint speed, I'm going to set it to 1200. And then for crouch speed, I'm going to set it to 300. And again, feel free to set these to whatever you want. Okay, so that's the first thing we want to do. So we can hook up our then 0 into here and drag this down like so. The next thing we want to do, well, let me look real quick. Sliding. Okay, so everything else has to do with sliding. So I think we will come back and do that later. So let's come back to where we were before. So we were inside of set movement state. So let's go back here. Okay, so we want to pass in our previous movement state. So if we drag in our local previous movement state, we want to pass it into this guy. And then after that, we want to basically look at what the new movement state is, and we want to call our events inside of our movement graph accordingly. So if we use our handy little macro, so we'll drag in our switch movement state macro and hook it up. So if we are walking or sprinting, so basically if our movement mode has changed to walking or sprinting, we basically just want to make sure that we are no longer crouching. So if we just come to our movement graph and we drag in the crouch, we can just call that. And I'm going to add a little reroute node here by double clicking and then hook that up. So that's all we want to do if we are walking or sprinting. If we are crouching, then of course we want to do the opposite. We want to make sure we are crouching. So we will drag in begin crouch and hook it up to crouching. And if we are sliding, then we actually want to make sure that we are crouching and sliding. So we'll drag in begin crouch, because obviously when you are sliding, you are actually crouching as well. And then we also want to drag in begin slide. So it should look like this. So if you're walking or sprinting, we want to make sure that we are no longer crouching. If we are crouching, then we obviously want to make sure that we are crouching. And if we are sliding, we want to make sure that we are crouching and then sliding. Okay, so we need to actually fill out these events. Let me make sure. Yeah, so let's go back to our movement graph real quick because we kind of left off in the middle of our sprint here. So we need to change this guy to be sprinting, because obviously, so when they press the sprint key, we set sprinting to true, and we set the movement state to sprinting as long as we are in walking or crouching. And then let's handle the released as well. So when we release the sprint key, we want to set the sprint key down to false. So I'm just going to copy this guy and then uncheck this and hook that up. And so again, we only really want to do something if we are in the correct state. So when they release the sprint key, we really only care about that if they are currently sprinting. Otherwise, we don't really care that they release the sprint key. So let's just copy this guy again. And then we want to say if they were sprinting, then we actually want to do something. So the thing we want to do in this case is we want to call resolve movement. Maybe we should call this resolve movement state. I'm going to rename this to resolve movement state, because that's basically what it's doing. And we want to hook that up to sprinting. So let's go ahead and start filling out this function. So the responsibility of this function is to kind of figure out what the movement state should be. So in other words, resolve the movement state. So we're saying we don't really know what state we're supposed to be in right now, but please go ahead and look, like, are we crouching? Are we underneath an object? Are we sprinting? Like, what are we doing right now? Figure it out and set us into the correct movement state. So that's what we're going to be doing inside of here. So the first thing we want to check is whether or not we can currently stand up. So if we drag in this can stand function, this is the first thing we want to check, except we want to change this to be a pure const function, so that way we don't have to drag in these execution pens like this. So if you just click on this guy, you can say pure, and then hit that little drop down and also change it to constant. And so let's go ahead and fill this guy out real quick, and then we'll come back. So inside of here, the can stand is basically going to return true as long as the crouch key is not down, because otherwise obviously we can't stand, and as long as there is nothing above our head. So the first thing we want to check obviously is if the crouch key is down, because that's a quick early out. So we'll say crouch key down, and we'll do a branch. And so if this is true, then we just want to go ahead and return false. So I'm going to add a output pin. So if we click on the function and add a new output parameter, we want to change the type of it to be a Boolean, and we'll just call this result. So if it's true, we just want to go ahead, like I said, and return false, because obviously we cannot stand if the crouch key is down. But otherwise, we want to do a line trace that goes from the character's feet to where his head would be if he was standing. And we want to check if that line trace hits anything. If it does, then we can safely assume that there's something above our head, and therefore we cannot stand up. So to do that, we want to get the actor's location. So say get actor location. And we want to add to that the height that he would be if he was standing. So, or sorry, let me clarify. So we want to get the actor's location, but if you look at the character, if you look at his actual origin, so if we select the character, see here, his origin is actually in his center. It's not at his feet or at his head, it's in his center. So we want to get this height up here. So in order to do that, we actually want to first go to where his feet is. So in order to do that, we're going to subtract the current capsule's half height. And you might be thinking, well, why don't we just add the capsule's half height? And we could do that, but the problem is that if he's crouched, this capsule is actually going to be a lot smaller. So if all we did was add the capsule half height, then that wouldn't give us a representation of where his head would be if he was standing, because the half height of the capsule would be shorter when he's crouching. So what we want to do is we want to subtract the current capsule's half height. So that's going to bring us to his feet, regardless of if he's standing or crouching. And then from there, we want to add twice the capsule's half height of when he's standing. So hopefully that will make sense when once we start coding it, but that's basically the idea. So we go back into our can stand. So we want to first go to his feet. So we want to subtract. So let's do vector minus vector. And then we want to subtract from the z. So if we split this guy up, we can specify just the z value. And so the z value is going to be half of his capsule height. So we'll drag in his capsule component, and we will say get capsule half height, and we want to use the scaled one just in case it's been scaled. So get scaled capsule half height, and that's going to be our z. So that's going to bring us to our feet. And then from there, we just want to add twice of our standing capsule half height, which is why we have this guy. Well, one of the reasons we have this guy. So we take in him. So this is half of our height. If we are standing, we want to multiply it by 2, so we get the full height. So full multiply by 2. And then we want to add, so we'll say vector plus vector. And then again, we'll split this guy because we only are adding to the z here. And we'll hook that up to the z. And so this is going to be the location of where our head's going to be. So we just want to do a line trace now from our feet to our head. So we'll say line trace by channel. And we're going to hook that up to the false. So the start location is going to be our feet, which is this guy. So I'll just add a little comment here so it's really clear. So this is our feet, and this is our head, basically. So we want to go from our feet to our head, and then we want to, I guess we don't really need to change anything else about this because it's already set to ignore self. Make sure you have it set to ignore self so it doesn't hit the player himself. I'm just thinking if you have like things attached to your player, maybe it might hit them and you might need to add them to the ignore list. But if you're following this tutorial, you don't have to do that. But I'm just thinking if you have other things around your character, like maybe you have a parrot on his shoulder or something, like anything that you don't want it to hit, obviously, when it's figuring out if you can stand, you want to add it to this ignore list. But we don't have anything, so we're not going to do that. Okay, so we don't really even care about what it hits. All we care about is if it hits something. So again, so we're checking if we can stand. So we basically want to take the opposite of this and return that. So we'll say not Boolean, and then I'm just going to copy this return node and hook it up. So if the line trace does not hit something, then we're going to return true, meaning we can stand, right? Okay. I guess one thing we should probably do before I forget is we need to set these variables. So the standing capsule half height and the standing camera z offset, we need to set these inside of begin play. So let me just do that before I forget. So come back here to the event graph, and let's come up here to begin play. So this is just a bunch of head-mounted display stuff that we don't care about. I'm just going to drag this guy over to the left here because we just want to add in a couple little things real quick. So we want to set these two variables. So I'm just going to drag both of these guys in and say set and set. Okay, so what we want to set them to is basically just what they currently are. So the capsule, standing capsule half height is going to be our capsule half height. And we'll say get, and for this one, I guess we can use scaled as well. Yeah, get scaled capsule half height. And the reason we're doing this is because if you were to later like go into your project or go into your viewport tab and change the size of this capsule, we'd want the code to still work. So this way it's kind of grabbing whatever you have it set to when it starts and saving it. And then for this one, we want the offset of the camera, because what we're going to be doing when you crouch is we're actually going to take the camera and move it down a little bit. So if you look at the camera, it actually has a location to it, and this is relative to the origin. So I'm just going to change this to a nice and pretty 65. instead of some weird number. So 65 is what it's going to start at. So that's the value we want to save. So back over here in our event graph, the standing camera Z offset, we want to set it to our first person camera, and we want to say get relative location, and we only care about the Z, so we'll split this guy, and we will hook up the Z like so. Okay, so now we have those two values saved before I forget. So where were we before we started doing this? We were inside of, so we finished writing can stand, and we were inside of resolve movement state, right? Okay, so let's go back here to resolve movement state. So now we have our can stand working. So from here, we want to do a select. So if we drag off this, we will say select, and then we're ultimately going to be outputting the new, or we're ultimately going to be calling set movement state, because again, the purpose of this function is to set the movement state to the appropriate value. So we can actually take this return value and hook it up here to the set movement state, just so we can get the correct type. So if we are standing, then we want to set it to walking. And if we cannot stand, then we want to set it to crouching. Now we're not quite done yet. We also want to make sure, we also want to take sprinting into account, because if we are sprinting, then obviously we want to be able to sprint as well. So that's why we have this can sprint function. So if we drag this in, we want to do something similar to what we just did for can stand. So we want to change it to pure and const as well. And then we want to fill out this guy. So this one's actually going to be a whole lot simpler. Basically, we just want to say that we can we can sprint as long as the sprint key is down, obviously. And we also want to make sure that we are not falling, like we're not in the air, and that we can currently stand up. And if all those are true, then we will go ahead and return true. So, like I said, the first thing we want to check our early out is whether or not our sprint key is down. So we will do a branch. So if it's not true, then we just want to go ahead and return false. So I'm going to add an output pin, and we will call this the result. And we will just say return, and we just want to leave this false. But the sprint key is down, then we want to make sure that we can currently stand. So we'll drag in can stand, because obviously we don't want to be sprinting if we can't even stand up. And we will do an and boolean, so and we want to and that with if we are not currently falling, so if we're not in the air, basically. So we'll drag in our character movement, and we will say is falling, which is just going to return true if we are in the air, basically. And we want to say not boolean, so we want the opposite of that, basically. And then we can just return this value. So if I just copy this return node, paste, look it up, like so. So again, just to kind of recap, all we're doing here is we're saying, just checking if we can sprint. If the sprint key is not down, then we just can automatically return false, because obviously we can't sprint. But if the sprint key is down, then it returns true if we can currently stand, and we are not currently falling or in the air. Okay, so now back here inside of resolve movement state, we can finish writing this function. So if the sprint key is down, again, we want to do another select. So we'll say select. And then we actually want to hook up this to the output, because this is going to be our true output. And so if we can sprint, then we want to set it to sprinting. But if we can't sprint, then we want to set it to whatever this returned. So we'll hook this up to the false. So this way it's going to figure out we're either going to be set to walking, crouching, or sprinting, depending on, whether or not we can sprint or crouch currently. And then that is what we want to return. So this is what it should look like. Again, just to kind of recap, we check if we can stand. If true, we set it to walking. Otherwise, we set it to false, or otherwise we set it to crouching. And then that goes into the false pin of whether or not we can sprint. So if we can't sprint, then it uses this. If we can sprint, then it just sets it to sprinting. And then it's called set movement state, and it passes in those values. All right, so now back here in our movement graph. Oh, we already wrote that. Okay, so that's good. So we should be able to test this now, at least our sprinting. So if we save everything real quick and we press play, if we press the shift key, you can see it starts sprinting. And if we release, then it stops sprinting. And I know it seems like we did a lot of work just to get sprinting working, but obviously we've done a lot more than that. We've set things up so that we can start writing code to crouch and slide as well. So we're a lot closer than you probably think. but make sure that your sprint key works. Pressing crouch right now obviously shouldn't do anything, and obviously sliding won't work quite yet. So we'll go ahead and do that in part 2. So this was mostly just the setup. Now we are really ready to go in and start writing our crouching and our sliding. All right, so I'll see you guys in part 2.